Hello, good morning, student. Today we will discuss circular motion. We are resuming our class after a long gap, and we will discuss circular motion. But before going to circular motion, let us recap what we have discussed till now. We have started the chapter with displacement, distance. Then we have discussed speed, velocity. Speed is scalar quantity, velocity is vector quantity. Then we have discussed acceleration, the rate of change of velocity. It is called acceleration, and the unit of acceleration is meter per second square. After that, we have discussed simple graph. This is suppose distance d and it is t. So this graph says that object is at rest. And if the graph is like this, the same displacement time graph, what it indicates? That object is moving with uniform velocity. So there are two types of velocity. There are two types of motion, uniform motion and non-uniform motion. After that, we have discussed velocity time graph, and we have discussed area under VT graph gives us displacement, velocity time graph, and these three equations. Now you are familiar with these three equations. V equal to u plus at, s equal to ut plus half at square, 2as equal to v square minus u square, where u is initial velocity, v is final velocity, s is displacement, a is acceleration, and t is time. We are also familiar with this graph. This is very familiar. And in this graph, the initial velocity is not zero. If it starts from this, the initial velocity will be zero. It has some initial velocity, and here we have time. So it is moving with some initial velocity with uniform acceleration because it is a straight line, and it reaches the final velocity v. So the velocity is changed in time t. So acceleration will be, because this is change in velocity, this is total v, this is u. So what will be this? V minus u. Hence the acceleration will be v minus u upon t. And if you cross multiply it, at will be v minus u, or v equal to u plus at. The first equation. Similarly, if you calculate the area of this rectangle and this triangle, you will get s equal to ut plus half at square. And if you take the area of trapezium like this two side and then this, then you will get, but again area, if you are calculating area under VT graph, gives us displacement, so it will give us the displacement. So this graph is very important as far as the equation of motions are concerned. Now, on the basis of equation of motions, we will solve few questions in text questions, although one or two questions we have already solved there. Now this is second question. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Now in this question, the speed is given 90 km per hour. But we have to convert that 90 km per hour into meter per second. See, this is the solution. 90 km per hour, it should be 90 into 5 by 18, so it becomes 25 meter per second. It is brought to rest, final velocity will be 0, and acceleration minus 0.5 meter per second square. Now we have to calculate how far it will go before coming to rest. So we will use v square minus u square equal to 2as. The final velocity is 0 minus initial velocity 25 meter per second. 2a is minus 0. Now see, when we say a is minus acceleration means retardation, and the object definitely is going slow, and it will come to rest after some time, into s. So minus 20, 0 will be 0, minus 25 square, it becomes 625, 2 into this, 1 into s, 1 minus n. Now this minus will cut, so s equal to 625 meter. Then the third question in the same in-text question. A trolley, while going down an inclined plane, has an acceleration of 2 meter per second square. What will be its velocity 3 seconds after the start? Now we have to calculate velocity in this question. So we will use, and what is given here? Acceleration is given, time is given, but we have to calculate velocity. And going down, so going down means the acceleration will be positive. Initial velocity is 0. So we will use v equal to u plus at. Now initial velocity is 0. At is 2 centimeter. Now don't change the unit here. If you will change the unit here, the answer will also change. So suppose 2 centimeter per second square, so we are writing that into time. So the answer will be v equal to u plus at, time is 6 centimeter per second. Now this is another question. A racing car has a uniform acceleration of 4 meter per second square. What distance it will cover in 10 seconds after start? Now in this question we have to calculate distance. In previous question, velocity. Now here we have to calculate distance. Acceleration is given, so we will use this formula, s equal to ut plus half at square. Initial velocity is 0, time is 10 seconds, acceleration is 4 meter. A car is moving, a racing car is moving, so acceleration, positive acceleration, so 0 into t, although time is given here, but 0 multiplied by 0, 0 multiplied by something is 0, plus half 4 t square 10. Now 2 into 2, so this will become 2, 10 square means it is 100, 2 into 100, it will be 200 meter. Hence the car will travel 200 meter distance in 10 seconds. Like this. Now suppose another question, same in text question. A stone is thrown in vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second in the downward direction. Now this is again very important point. The acceleration is downward direction. Suppose car is going here and acceleration is here, so it is called retardation. Now the stone is thrown upward and acceleration is here, so this will be negative acceleration. This acceleration is negative acceleration. So let us see the question. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Height and time, these two we have to calculate. So let us see. Initial velocity 5 meter per second, and now see the acceleration because it is in downward direction, so minus 10. So we can use v square equal to v square minus u square, it is equal to 2ah. So it will become v square minus u square upon 2a equal to h, and this is only written here, square minus u square upon 2a. So final velocity will be 0, initial is 5, 2a, acceleration is minus 10. So the answer is 125 meter. Now how long it will take, how much time it will take to reach there? We will use v equal to u plus at. U is 5, final velocity is 0, plus a minus 10. And here we will write minus 10 into t. So 5 into t is minus 10t. So this 5 equal to 20, t equal to 0.5 second. So the final answer will be 0.5 second. So the stone will take 0.5 second to reach at the maximum height. Like this, we have discussed many questions, and these questions were left. So you do the revision of these questions. Now we will start our circular motion, today's main topic. See, the sun and planet. Although the planet moves around sun in elliptical orbit, but it is considered almost circular motion. Earth and Moon, the circular track, the players see here. This is the circular track, circular ride, and this is the electron moves around the nucleus atom. All these are the examples of the circular motion. So how circular motion? And since we have discussed till now, we have discussed the translatory motion, in which the object was moving in a straight line. Now it will move in a circle. So again we will get all the same things: velocity, distance, displacement, acceleration. Okay, so what is circular motion and how it is related with linear motion? Now suppose you are going from A to B in a rectangular track, B to C, C to D. So how many times you are changing the direction? Suppose you have started from A, 1, 2, 3, 4 times. Now in hexagon, if you are starting the motion from point A, so you are changing the direction. See, we are discussing the circular motion, but we are discussing the uniform circular motion, in which the speed of the particle remains same, but it is changing the direction. Here it changes the direction 4 times, here 6 times. See, this in the hexagon, it changes the direction 6 times, and this is octagon. Now in this case it will change A to B, B to C, C to D, D to E, E to F, F to G, G to H. So here in this case the object will change the direction 6 times. Earlier this number of side was 4, then side becomes 6, now the side becomes 8. Now see, when we go from 4 to 6, 6 to 8, almost it is becoming circle. Now if you get more octagon, then suppose if you take a geometry having 12 side, so the particle will change the direction 12 times. And if you are taking a geometry of having 100 side, so it will change the direction 100 times, but the side of that geometry in which each side will be very small. In 8 also this side is very small. Now if you want to convert it into a shape of having 100 turns, 100 times, suppose the direction is changing 100 times, 1 2 3 4 5 6 7 8 9 10 91 92 93 100. So when it is changing 100 time direction, so what will happen? It will almost become a circle. If the athlete moves with the velocity, constant velocity, so what he is changing? Only the direction is changing. So speed is not changing. The motion of athlete along a circular path is therefore an example of accelerated motion. Now here suddenly the acceleration word comes. Now a simple question arises in mind. If the velocity is 20 meter per second, 20 meter per second, 20 meter per second, the velocity is not changing. Here also 20 meter, here also 20 meter, 20 meter, 20 meter. Then how it is accelerated motion? So in uniform circular motion, speed will remain same. The magnitude 20 meter will remain same, but it will change direction. So the acceleration will come due to change in direction. In uniform circular motion, or what is uniform circular motion? The uniform circular motion is that motion in which the speed or magnitude of velocity remains same, but particle changes its direction. And since it changes the direction, therefore acceleration comes. And it is an accelerated motion. Now we know the circumference of the circle of radius r is 2 pi r. Now if it starts the motion from this point, it will travel 2 pi r distance in time t. So velocity equal to distance upon time. If athlete takes t second to go once round the circular path, then velocity will be given by this. This kind of motion is called uniform circular motion. You can do this activity. Take a piece of thread and tie a small stone of piece at one of its end. Move the stone to describe the circular path with constant speed by holding the thread at the other end. Now when you are moving and if you are releasing, in which direction it will go? So if you are releasing, the stone will go here. It will, suppose you are releasing at this point, so the stone will go here. Now the stone is moving and you are releasing here, so it will go this side. So it will go along the direction of the tangent. See, this is person. So when you are releasing the stone, it will go, the stone will go this side. Stone will go this side along the direction of tangent, and acceleration will be toward the center. This is an example of uniform circular motion. Uniform circular motion is that motion in which the acceleration arises due to change in velocity. Okay, thank you.